This problem is going to give you a chance to kind of wrap your brain around composite functions a little bit more. It says the population of an insect colony is growing at a rate of 1.5% per week. Write an expression for the function n of p that gives the population 1 week after the population is p. Okay, so I guess the best way to start out with this is just to kind of think about the fact that right now, okay, right now, the population is p, okay? So for letter A, if we want to know what the population is 1 week, if it's growing at a rate of 1.5% per week, let's just start with n of p equals, we know the population right now is p, plus it's going to grow at this rate, 1.05, which is to say 0.015, right? Okay, so plus 0.015p. So that means that after the first week, and that's what we're looking at here, 1 week, right? So we've got the first week is equal to 1.015p. Okay, now I'm aware that we don't really care what's going on during week 2, but we're going to need to go there to help us get to the 3-week population, okay? So for letter B, we want to know what's going on during the 2nd week, all right? Okay, well, the first week, if the first week the population was this, 1.015, okay? So if that's what the population was the first week, then it's still growing at this rate, right? So that means that we have this, and we're plugging this into the p function, right? Okay, so that's where this number right here is right here, okay? And then this whole thing is getting plugged into the p spot right here. So we have 1.015p, okay? Now what that really means is that we have 1.015 squared p, and that was for the 2nd week, right? Okay, so for the 3rd week, we can keep going along with that same idea. N of n of n of p. Do I need one more set of parentheses here? Yes. Equals 1.015 cubed p. All right, so now that you've kind of established that pattern, you could find the population, the composite function that gives the population after, 200 weeks, right?